Welcome to the DIY Honda Garage channel. DTC P0328 signifies a problem related to the knock sensor circuit high voltage in the 2012-2017 Honda Accord. The knock sensor is an essential component that detects engine knocking, which is essentially abnormal vibrations occurring during engine operation. It is located on the engine block, acting as a piezo-ceramic element that converts vibrations into electrical signals. The Powertrain Control Module, PCM, uses these signals to adjust the ignition timing to optimize engine performance. If the knock sensor's output voltage exceeds 4.50 volts for more than 2 seconds, the PCM interprets this as a fault, resulting in the DTC being stored in the system. Diagnosing this issue accurately is crucial to ensure the smooth operation of the engine and to prevent potential damage. Preventive maintenance plays a vital role in prolonging the life of the knock sensor and the engine overall. Regular diagnostic checks can help identify issues before they escalate into major problems. Inspecting the knock sensor periodically, along with its wiring, can prevent potential failures that may lead to DTC P0328. Ensuring the integrity of wiring, checking for frays, disconnections, or corrosion can prevent electrical issues that would affect sensor signaling. Preventive measures are essential to maintaining optimal engine performance and avoiding costly repairs down the line. In conclusion, DTC P0328 provides critical insight into the performance of the knock sensor within the 2012 to 2017 Honda Accord. Understanding its function, location, and potential malfunction causes is crucial for effective troubleshooting. By following a systematic approach to diagnosing this DTC, checking for related codes, inspecting wiring, testing the sensor, and reviewing the PCM, you can accurately pinpoint the underlying issues. Additionally, preventive maintenance practices can further extend the life of these components and enhance overall vehicle reliability. Addressing this DTC promptly not only improves engine performance, but also safeguards against further complications, ensuring a smoother driving experience. The knock sensor, a critical component mounted on the engine block, plays a pivotal role in engine performance by detecting knocking. This knocking refers to abnormal combustion that can cause damage if unaddressed. Its operation hinges on converting the vibrations from these knocks into electrical signals through its piezo-ceramic element. These signals are sent to the Powertrain Control Module, PCM, which interprets the data to adjust the ignition timing, thus optimizing combustion and performance. The knock sensor's location on the engine block makes it directly responsive to vibrations. If these signals rise above the threshold of 4.50 volts for 2 consecutive seconds, the PCM triggers the DTC, alerting the driver to a potential issue. Several potential causes could lead to the triggering of DTC P0328. One primary reason is the failure of the knock sensor itself, which might occur due to wear or damage. Another cause could be an open circuit in the knock line, which interrupts the signal from the knock sensor to the PCM. Similarly, an open circuit in the KS-GND line can prevent the knock sensor from grounding properly, leading to a false reading. Additionally, an internal failure in the PCM can also produce this high voltage indication, as it may not process the signals accurately. While these are the most common causes, it is essential to consider that there could be other underlying issues contributing to this problem. When experiencing DTC P0328, a range of symptoms may become evident. One common symptom is engine misfire, which occurs as a result of improper ignition timing caused by faulty signals from the knock sensor. Drivers may also notice rough idling, leading to a jittery operation of the vehicle at stoplights or during low-speed maneuvers. Additionally, decreased fuel efficiency may present itself, as inefficient combustion stemming from timing issues can result in overfueling. The most telling sign is often the illumination of the check engine light, which directly alerts the driver to a malfunction in the engine management system. Being aware of these symptoms can help in diagnosing the problem early and mitigating further damage. The first step in troubleshooting DTC P0328 involves checking for any DTCs present in the vehicle's onboard diagnostic system. Utilizing a scan tool is essential for this process, as it allows access to the vehicle's computer where diagnostic trouble codes are stored. Once connected, the tool can confirm the existence of DTC P0328 and identify any other related codes. If additional DTCs are present, they must also be addressed before focusing solely on P0328. This step helps to assess if the issue at hand is isolated or part of a larger problem affecting the vehicle. Ignoring other codes could lead to misdiagnosis and prolong the repair process. In the second troubleshooting step, it is critical to inspect the wiring connected to the knock sensor. This includes checking for any physical damage, such as cuts, frays, or disconnections that might affect the sensor's ability to communicate effectively with the PCM. Any visible signs of wear should be promptly addressed, and wiring terminals should be examined for corrosion or looseness that could cause erratic electrical signals. A poor connection can lead to high voltage readings, falsely triggering DTC P0328. Ensuring that all wiring and connections are secure and intact can prevent miscommunication between the knock sensor and the PCM. The third troubleshooting step is to test the knock sensor directly. Using a multimeter, you can monitor the output voltage of the knock sensor while the engine is running. It is critical to refer to the manufacturer's specifications regarding the acceptable voltage range for proper sensor function. If the output voltage exceeds 4.50 volts, as indicated in the DTC description, it confirms a fault with the sensor. This testing can provide significant insight into whether the knock sensor is actively functioning or if it has failed. Accurate measurements will guide further repair decisions and validate the condition of the sensor itself. In the fourth step, examining the powertrain control module, or PCM, is essential to confirm that it is functioning correctly. This component is responsible for interpreting signals from the knock sensor, and any internal faults may lead to inaccurate readings. Checking for diagnostic trouble codes stored in the PCM can also offer insights into its performance. If issues are found within the PCM, replacement may be necessary to resolve persistent DTC P0328 issues. Given the complexity and importance of the PCM in overall vehicle operation, this step is critical for restoring proper control over various engine functions and ensuring long-term reliability. To confirm that the issue related to DTC P0328 has been successfully resolved, the final step involves clearing the DTCs from the vehicle's memory. This can be accomplished using a scan tool, which will reset the system and allow you to perform a test drive. During the test drive, it is critical to monitor for any recurrence of the DTC. If the knock sensor operates within the specified parameters and no new issues arise, it confirms that the repairs have been effective. This verification process is essential to ensure that the corrective actions taken have fully resolved the issues affecting vehicle performance and reliability. Please like and subscribe to the channel. See you next time.